everyone. My name is Yue. I'm in computational linguistics group with Professor Gerald Pan. Today, my topic is about reachability problems for vector addition systems. So firstly, I'm going to talk about what is computational linguistics. Computational linguistics has both theoretical component and applied component. For example, speech recognition is a kind of application in computational linguistics, such as Apple's Siri. And nowadays, more and more people are doing research on natural language processing using methods of machine learning. But computational linguistics also has its theoretical component, such as discrete mathematical models of sentence structures, which is very similar to automaton theory. And what is reachability problem? Reachability problem is actually a fundamental problem for most theoretical areas. Given a computational system with a set of transformations, reachability problem is to decide whether the final state is reachable from the initial state in the system. Here is an example of reachability problem. We have an initial point, a final point, and a set of vectors. So we start from the initial point and use the vectors in the set to reach the final point. So in this case, the final point is reachable from the initial point. So the most important thing in vector addition system is the set of vectors. A vector addition system is basically augmenting vectors to some system. For example, we can augment vectors to automaton. So here are some definitions for separator and domain. A pair x, y is a separator if any vector in y is not reachable from any vector in x. So anything outside x and y is in the domain. So here we can see we can put the initial point in a set and put the final point in another set, and the combination of these two sets is a separator. So according to this theorem, we know that we can always span the sets in the separator to get a new separator which has a smaller domain. So in this case, we can always span the set of initial point and the set of final point, and finally we can maybe we can get two new sets which can be combined into a separator with empty domain. So if we can reach that stage, which means if we can get a separator with empty domain, which means this theorem is terminant. And in this case, the final point cannot be reached from the initial point. Otherwise, the final point can be reached from the initial point. So next, vector addition tree automaton is a kind of automaton. I think the difference between vector addition tree automaton and normal DFA or NFA is that we actually augment vectors to each state. And if a state is pointed by multiple states, the value of that state depends on the value of all the values in the states pointing to it. So actually, here is an example of vector addition tree automaton, we think we can use the method. We think we can use the method for general vector addition system to prove the reachability problem for vector addition tree automaton, but we are not sure, so we are still working on it. So that's it. Thank you.